Right, this is May-June 2022, paper 22. It says underline which are the SI base units. This was very straightforward. So ampere is a base unit, kilogram is a base unit, right? Newton is actually F equals to MA as kg, ms minus 2. And degree Celsius is not the base unit of temperature. It's actually Kelvin, right? So that's why it's wrong. Okay, so he says that this is the direction of oscillation. Okay, fine. We're not concerned with the formulas, but we do need to understand what each variable represents so that we can at least calculate the units or whatever the type of question may be. M is the mass and T is the period, K is a constant. Percentage uncertainties are given to you. He said calculate the percentage uncertainty in E. So we need to understand how E is being calculated. You see, if I wanted to make the error function of E, that would have been change in K divided by K. Plus a change in M divided by M. And if K is a constant, then of course it is assumed that its value does not change. So K might not be a participant of this. Delta M by M plus delta T by T. But since this has a square in it, so that will be a power function multiplied by 2 divided by T, right? So this is what our expectation is. But since we can see that K also has an error, so K will also be a participant of this divided by K, right? So the whole percentage of this, when it is being calculated, will give you an answer of 2.1%. This will give you an answer of 0.6%. This is what this table means, right? That if you were calculating them individually, this is what the answer will be. But the problem is that when there is a power rule, you will only see that this is 1.5%, right? You have to multiply this to after the calculation. So very straightforward, we can see that K does not have a power. So this will simply be added together, 2.1% plus 0.6% plus 2 times multiplied by 1.5%. Because T had a square, a power rule will be applied over here. And the answer of this will be 5.7%. Which means that if E had been calculated with this data that is given to you, then the value of E would have had an error of plus minus 5.7%. Okay, then he says to calculate the absolute uncertainty as usual, right? How would you do that? Because he has given you the value of E over here. He says that the calculated E is actually this one. When K, M, and D are going to be put in. So how to determine the absolute uncertainty? Simply multiply the percentage uncertainty with the calculated value that you already have. So 8.45, where the function goes something like this, that delta E divided by E is equal to right now 5.7%. We have the value of E, so let's take it over there. So delta E, or the absolute error E, would have been equal to 5.7 divided by 100 multiplied by 8.245 multiplied by 10 raised to power, I think it's 9. Yes, that would be 9. Now, when you calculate this absolute error, you will find that this comes out as 0.469 into 10 raised to power 9. How to write this down? So E goes to 2 significant figures, so this will be 8.2. And you can notice that the 10 raised to power 9 is already mentioned, so I will not mention this over here. It will be wrong to write down 10 raised to power 9 again. This is wrong. Now, how to mention the error? We know that errors are up to 1 significant figure, so this will be rounded off to 0.5, plus minus 0.5. But power 10 is already mentioned, so no need to write this down. Question number 2 is from dynamics. Let's see what he says. Okay, direction of flow of water. There is a wire, there will be tension in the wire, fully submerged and in equilibrium, which means that the weight is equal to the upthrust and the tension component provided by the wire. Horizontal surface, okay. Weight is 30 newtons, upthrust is to 80 newtons, the density of the water is given to you. Okay, fine. Assume the forces of sphere or flow are in the horizontal direction. Okay. So this is primarily in the horizontal direction, right? Okay. By considering the components of forces in the vertical direction, determine the tension in the wire. You see, in the vertical direction, we can see that there is a weight of the balloon, let's say sphere, that is 32 newtons. And there is an upwards thrust of 280 newtons. Now, of course, the weight cannot keep up with the upthrust. So that means some of the tension must come, or some of the downward force must come from the tension. That is why the system is in equilibrium. So if I mention, or if I draw the components, one of them should be in this direction and one of them should be in this direction. Simply put, So the angle in front of, or the component in front of the angle is generally t sine of 68, and one in the horizontal direction will be t cos of 68. We have this shortcut from vector components video that I've already explained. So let's find out what's happening vertically. So the sphere experiences 280 in the upwards direction, 32 in the downwards direction, and also a component that is t sine of 68 in the downward direction. So everything is balanced. So that means 280 should be equal to 32 plus t sine of 68. 32 goes over there, gets subtracted, and then sine 68 gets divided by the remaining answer. So your answer of t will be equal to 267 newtons, which up to two significant figures becomes 270 newtons. Be advised that this is the answer for the tension completely. This is not the answer for the component. This is the complete tension in the wire. Okay, so then he says for the sphere, calculate the volume. So we know the Archimedes principle, which is F equals to rho GV. The upthrust was equal to 280. The density of the water in which this is placed is 1000 kilograms per meter cube. So 1000. G is 9.81 and V is the volume of the displaced liquid, which was displaced by the sphere itself, which it would be 0.0285. So this becomes 0.029 meter cube. The density, so that is simply density is equal to mass over volume. He says that the weight of the sphere was 32 newtons. So I will use this to find out the mass by using W equals to mg. So that simply becomes 32 divided by 9.81. This becomes the mass of the sphere, and the volume was found in the previous part, which is 0.029. So that is going to be this way. So this comes out as 112 kgs per meter cube. So this is going to be 110, up to two significant figures. Moving on to this part C, he says that the sphere has initial height of 6.2. Above the horizontal surface, the speed of the water increases. Okay, fine. Causes the sphere to move in a different position. This movement of the sphere causes gravitation to decrease by 77. Yes. Calculate the final height of the sphere above the horizontal surface. You see, if you increase the speed of water, right, the sphere is going to move in somewhat this direction, right? Although it is being influenced by high speed of water, if you look closely, the center of gravity has actually fallen down. Previously, the center of gravity was at this point. Let me choose a different color for this so you can see it properly. Center of gravity was at this point. Now the center of gravity is this point. So considering from the height from the horizontal surface or from the base, the center of gravity has fallen down, which is why he says that the gravitational potential energy is being lost. And this was your hint to understand this as well, that the balloon is going to come down. Only when you come closer to the surface of the earth, you are losing gravitational potential energy, right? So how to solve this part? First, we find out the change in gravitational potential energy. So we can find out the change in height. So that would have been mg8. So how much energy has been lost? 77. Mass would have been 32 divided by 9.81, and g is 9.81 again. So they get cancelled out. So we are just left with 32. And this is h. So h comes out as 2.4 meters. Since it is a loss of gravitational potential, this would have been a movement downwards. So if the previous height of the balloon above the surface was 6.8 meters, it has lost 2.4 meters. It is the so how high above is this from the surface? That would lead to 8 minus 2.4 equals to 3.8 meters. So we would have written down 3.8 meters. Okay. Part D1, the extension of the wire increases when the sphere changes position. ठीक है. State a simple equation that gives relationship between T and the wire X. Identify the symbols that you use. Simple as that, we know that the Hooke's law is equal to F equals to Kx. Now, since we have a tension T in the string, that will be replaced in place of F as T equals to Kx. So T equals to Kx, and then you're going to write everything in English that K is a spring constant, right? X is the extension, and T is the tension or the force in the wire. Simple as that. Because he says that you need to identify your symbol so that he understands that whether you're using E for extension, X for tension, what do you mean by T? What do you mean by spring constant? Do you have an idea of that or not? Before the sphere changed position, the initial elastic potential energy of the spring was in the wire was 0.65. The change in position caused extension to double. Now this is a ratio method question. Calculate the final elastic potential energy of the wire after the sphere has changed position. Okay, no problem. First, we need to understand that the kinetic and elastic potential energy is equal to half kx square. Right? So we understand that elastic potential energy is proportional to x square. Okay, fine. Now, when we move on to this idea that if we want to make a mathematical equation out of this for simple ratio, you see, if we have a relationship between two equations, or at least two variables, I can do this mathematically, that instead of finding this answer first, finding or using 0.65, then finding the initial extension, then finding the final extension, instead of doing this, I can just do the ratio method. I can just do the comparison. How can we do that? You can divide the old system with the new system, or new system with the old system. So that system looks something like this: E1 divided by E2, and of course they will proportional to their respective extensions. X2 square, this was also proportional to that, but we've divided the whole system. What this does is that this converts this proportionality into an equality. So this formula becomes E1 divided by E2 equals to x1 square divided by x2 square. Why? Because if you want to convert this proportionality into an equality, you needed a constant. And since you are comparing this two variables, or these two variables, that means the rest of everything would have been constant. So even for this, the constant would have been same. So constant cancels out, and you're left with this comparison ratio equation. Right? This is mathematics. This is not physics. But anyways, let's use this trick to solve this question quickly, because this is only for 2 marks. No need to waste a lot of time on this. So let's say that this is the new energy as En, and this is the old energy as E naught. The new energy is what we don't know, but we do know that the extension has been doubled. So 2x into whole square divided by the original extension was x whole square, right? So, and we know that the original or the old energy was 0.65 as given in the question. So there is 0.65. So that goes to that side for cross multiplication. What we left with is 4x squared divided by x squared multiplied by 0.65, and we are left with 4 multiplied by E naught, because x square cancels out, and this left us an answer of 2.6 joules. A student could have approached with the ratio method, or at least a logical explanation as well, that since the elastic potential energy is square of the extension, so if the extension has become doubled, the elastic potential energy would have become at least 4 times. And then they could have done this process as well. That would have been acceptable as well. Okay, so the answer is 2.6. So I've explained the maths of it, and I've also explained the logical reasoning behind it as well. Okay, question number 3 seems to be a question from kinematics, but anyways, let's start. Is standing 3 meters above from the point of release. The initial velocity is 5.6, 3.1 above the ground. Okay, assume that air is okay, fine. Show that the ball has a maximum height of 4.7. You see, he's already at 3.1. How high it can go? But we will assume that if it is released from this point, when it reaches the highest point, its velocity will become 0 for that point momentarily. We can find this change of height and then add 3.1 into it so that we can know how high above it is from the ground. So using this logic, we can simply use the equation S equals to ut plus half at squared. Or we can use, we don't have the time for this, so we can't use this. We can use v square equals to u square plus 2as. Yes, this will be a better option. So we have the final velocity is 0 square. The initial velocity is 5.6 whole square. And since it is moving against gravity, so 9.81, negative 9.81 s. By the way, I've explained it in my videos as well, that you don't need to put in this negative sign. You don't need to worry about the negative sign, because when you take this over there, this is going to become negative. This negative cancels out. So even if you were for solving it with a positive sign, it wouldn't matter. Anyways, that's your choice, how you want to observe this, how you want to view this situation. So this S is going to come out as, let's solve this. So this is 5.6 whole square divided by 2 into G, 9.81. This comes out as 1.59 meters. Let's add this 3.1 meters with it. So distance or displacement from the base is 4.69. It comes out 4.69 meters. And he says we have to show that it's 4.7. We have successfully shown that it is 4.7 meters. But by the way, also note one point, that whenever you encounter this show that part, it means that if you're unable to solve this part, please make sure that you use this value for the next part, so that you don't make an error for the next part at least. Okay, part B. The man does not catch the ball as it falls. Okay, calculate the time taken for the ball from its maximum height to the ground. No problem at all. Now it is at 4.7 from the ground. It is 4.7 meters away from the ground. Its initial velocity is 0. So we're going to use the formula S equals to ut plus half at squared, because we want to find the time. Now, since the initial velocity is 0, this whole component becomes 0. We are only left with S as 4.7. Ut is 0 plus 1 over 2. The acceleration is due to gravity, so 9.81 into t squared. So our t squared comes out as, or after taking the under root, comes out as 0.978, which is 0.98 up to 2 significant figures. Moving on to the next part is question number C. He says that the numerical values of V and T are not required, but if they were required, you already have those values, what velocity it was released at, and what velocity it will gain when it actually falls down again. But anyways, let's try to solve this in terms of simple physics. He says that it hits the ground at time t equals to t. No problem. What you need to understand is that the moment it was released from the hand, the velocity was, let's say, 5.6 at this point. But when it's going to come down, its velocity is going to be a bit higher than when it was released, because it has to cover a larger distance to come down, as opposed to when it was released in midair. Okay, so, and since it is actually under the influence of gravitational acceleration, okay, so we'll have to draw a constant straight line with a negative gradient that goes down up to this point. But just a moment, something like this. But it will be a straight line, yes. Although values are not required for this part, but if you try to practice it with the values, that would be better for you in future for next incoming past papers. State the represented gradient. So we understand that this is the acceleration of free fall. This is what I've been discussing up to now. This is acceleration of free fall, or simple acceleration would have sufficed for this question as well. Then we have part E. He says that the man throws a second ball with the same velocity from same height as the first ball. The mass of the second ball is greater. Assume that air resistance is still negligible. For the first and the second ball, compare the magnitudes of their acceleration. That will be same, because the value of acceleration is 9.81, and the equations of kinematics that we use, that is v square equals to u square plus 2as, and s equals to ut plus half at square, and for that matter, v equals to u plus at. They all do not care about the mass of the object. All they care about is acceleration, right? And for the gravitational attraction or the gravitational systems, we assume that it is 9.81. The speed at which they hit the ground, again, it will have been the same if the air resistance is negligible. If, however, air resistance was present, then the heavier ball would have an advantage in terms of falling with a greater speed if they had the same volume, right? All right, so we move on to next question number 4. So question number 4 suggests principle of conservation of momentum. You have to write this in English. That is that the momentum, total momentum before collision is equal to total momentum after collision. By the way, this symbol is for mathematics and this is used for sum. So when you write this in English, it is sum of total momentum before collision is equal to sum of total momentum after collision. This only gives you 1 mark. What is the condition when this is true? That there is no external force acting. Only then this can be true, right? Okay, so we move on to part B, that is 2 balls between X and Y, moving horizontal frictionless. Okay, fine. The ball X has a mass of, okay, so they have different masses, different velocities, and everything is given in the question in terms of diagram as well. So then they stick together. So when they stick together, this is 100% an inelastic collision. This is my prediction before, or you can say a trick point before we proceed with the question. He says find the angle theta. Okay, no problem. So you can see that before they come into the system, or before they come into collision, they have a respective y-axis component in these directions, and they have an x-axis component in these respective directions for both of them, right? And when they collide and start moving towards the right side, I can see that there is only an x-axis component. The y-axis component is missing, which gives me the 100% guarantee that the y-axis component of A and the y-axis component of this particle y would have been equal. Although there is no utility for this equation because they're equal, but for the sake of understanding, I can write this down as that the momentum of x, which is 3 multiplied by 4, but since I'm looking at this component, that would have been sine theta, must have been 100% equal to the momentum in the y direction of a y particle. So that would have been something like this: mass, which is 2.5, into velocity, which is 4.8, into the y-axis component, which is going to be sine theta. So this is going to be sine theta. They would have been equal. Or one another way to visualize them would have been this way, that if you add them together, the answer would have been 0, because one of them is negative and one of them is positive. Downwards are negative, upwards are positive. So simple understanding is, if you bring that equation towards this side, this becomes negative and this leaves 0 on the other side, right? So this is just mathematical manipulation. Anyways, let's go back to the question. It says, considering the components of the momenta along line AB, calculate theta. We can see that y-axis serves us no purpose. We can't use it to solve it. Okay, let's find out the x-axis component, right? So what are the x-axis components for this? X. So for the x sphere, I'm going to write this down over here so that you can relate to the diagram at least. So we have the momentum as 3 kg multiplied by velocity, which is 4. But since we are moving in this direction, I will use the component of cos theta. Since this component is also in this direction, I will add this with the other component, which is going to be 2.5 into 4.8 into cos theta once again. And this is equal to the momentum of the whole system. So since they are sticking together, their masses will be added. So 3 kg plus 2.5. So 3 plus 2.5 into the velocity, which is 3.7. This will be the equation that is going to help us find out the sine, the cos theta, or the angle at least. Now, it is all about algebra. That's up to you. You have to perform it. It's not my job. But anyways, I can still guide you for this. If you calculate all of them, this is going to be 12 cos theta. This also comes out as 12 cos theta. This comes out as 20.35. Now, when you solve this, you get theta as 32 degrees. So the answer of this part would have been 32 degrees. Anyways, by calculation, now he says that you have to do this by calculation. By calculation of kinetic energies, because he knows some of the students, some of the good students have remembered that sticking together gives you an inelastic case. He's going to force you to solve a question so that you can at least prove this. So no problem in this. We are going to simply add the kinetic energies of, or compare the kinetic energy. So how can we do that? So we are going to make the old kinetic energy system, which is going to be the kinetic energy of both objects combined together. So that would have been 1/2 half into mass of one of them is 3 kg. Its initial velocity is 4 square plus half into mass of the other object was 2.5 and its velocity was 4.8 whole square. When you find this out, this answer is going to be 52.8 joules. Remind you, I'm telling you that sticking together is an inelastic case, but let's see whether it's true or not. What happens after the collision? They're both moving together in a certain direction. Okay, fine. So the new system is 1/2 mass combined. So I'm going to add them together. So this becomes 5.5 kg. Their current velocity is 3.7 whole square. When I calculate this, I find that this is 37.6 joules. You can see that they're both not equal. So now you will write this down in English, right? That the kinetic energy before and after the systems are not equal. So you can say that the kinetic energy before is not equal to the kinetic energy after. Hence, this is an inelastic collision. Inelastic collision. So the conclusion will be inelastic based on the data that we've calculated. Okay. Question number 5 seems to be from waves and interference patterns. All right. We have the wavelength of light. We have the gap. Now, since this is a double slit experiment, because there are only 2 openings, the formula that I should look forward to is AX equals to lambda t. This is the formula for the question. I have the lambda, which is 660. I have the gap width, which is A. Right now, so far, D is also given to us as 1.8. So we can easily figure out the fringe separation, that is the distance between dark to dark and bright to bright. But let's see if that's asked in the question. I've just preemptive understood the question and tried to give answers. He says, what's meant by coherent? As discussed earlier many times, that coherent actually means that there is at least no phase difference. Either there is no phase difference, and even if there is a phase difference, that phase difference has to be a constant phase difference. For example, if two sources want to move along at different angles momentarily, for example, one wave is going like this, one wave is going like this, then okay, fine, it is acceptable. But the phase difference between them, the angle between them, the theta between them should remain same, no matter where they are, right? Only then we can see this interference pattern. He says, find out the difference in their path lengths in nanometer from the slits. Now, here comes a shortcut. You see, he is going to compare for two lights superimposing at R. He's talking about the coordinate R. Now, R is a dark fringe. I've explained this trick before. I'm going to explain it again. There is a shortcut for path difference and angles. I'm going to explain all of them at once right now. Okay, so at the very center, the path difference, the central fringe is 0 lambda, and the phase difference is 0 degrees. When you move on to the next dark fringe, the P coordinate, this path difference would have been 0.5 lambda, and the phase difference would have been 180 degrees, right? This is what you see as the formulas in the books that are given to you, that this is going to be an odd number, this is going to be an even number. Let's forget about that. So the very first time you see the bright fringe after the central bright fringe, this will have a path difference of 1 lambda and a phase difference of 360 compared to the original bright fringe or the central bright fringe, right? Now, if you have identified the pattern, you will see that when you move to the next dark fringe, this will be 1.5 lambda path difference and 540 degrees of phase difference. How do you get this 540? You see, when you have to move from bright to bright, you simply keep on adding 360 degrees to the next answer. For example, if there had been a next coordinate with a bright fringe in mind, like this one, this would have been having a path difference of 2 lambda and a phase difference of 360 multiplied by 2, which would have been 720. So consecutive bright fringes have a phase difference of 360 and 360 and so on and so forth. And notice that their path differences are whole numbers. But for the dark fringe, there is always going to be a point of 0.5 or a factor of 0.5 included in them, right? So this is the trick, okay? And the next trick about their angle is that the very first time the dark fringe forms is at a phase difference of 180. The rest, all of them will be formed after an angle difference of 360 degrees added into them. So if I had to predict the next dark fringe, that would have had at 540 plus 360, but it would have been at 2.5. So you can see that there is a pattern of 0.5, 0.5, 0.5. The bright fringes are formed when there is a whole number, when there is a constructive interference. Dark fringes are formed when there is a destructive interference. And what is this 0.5 lambda? What's actually happening at this coordinate? Let's discuss that in terms of a little bit of in-depth analysis. So what's happening at the 0.5 lambda interface? You see, one wave is coming from this source like this, reaching P, and we can see that in the last phase of P, this was a crest. Now, when we talk about the second wave coming from the second source, which is coming from the other gap, that is going to go like this. When it comes to the end, it goes through a trough. So there is a gap between them of at least half a wavelength. Why? Because if one wave is at, let's say, a crest phase, and the other wave is moving or coming from another side and having a trough, they are half a wavelength apart from each other. That's why there is a difference of 0.5, and that's why, since a crest meets with a trough, this has a positive amplitude, this has a negative amplitude, it gets cancelled out and leaves a dark fringe behind. So these are the tricks and the logics behind them. So he says to predict the path difference in terms of lambda, we know that R is actually at 1.5 lambda gap. So we know that the lambda is 660. So that should be 1.5 multiplied by 660 nanometers. So this comes out as 990 nanometers. Okay, so their phase difference, of course, at R, we had figured it out that this was 540 degrees. This was 540. Calculate the distance OQ. So for OQ, what is the distance OQ? Yes, for OQ, we first need to find out the X. So how do we find X? We use this formula for double slit experiment. That is going to be AX equals to lambda D. So what is A? A is 0.44. Don't forget this is millimeters. And X is what we want to find out, equals to 660 nanometers. So 660 into 10 to the power minus 9. And D was 1.8. So X comes out as 2.7 millimeters, right? So your distance OQ, O to Q, is the first bright fringe. Let me erase this situation from this. O to Q is the first bright fringe. So the distance is from bright to bright. This is X. And if it had been between dark to dark, that would also have been X. So dark to dark would also have been X. So this X in the formula is the distance between bright to bright or dark to dark. That's your choice. Okay. All right. So this was already a bright fringe distance. So that's why we're not disturbing this. So this will be left as it is, 2.7. He says that the intensity of light is incident as double slit is increased without changing any of the frequency. So how is the appearance going to change? You see, if you increase the intensity, the formula for intensity is power per unit area. So power watts per meter square. So if you increase the intensity, that only means that you've increased the light intensity. You've only increased the energy of the light. So what's going to happen? There will be no physical change in the distance. There will be no physical change in A, X, lambda, or D. Nothing is going to change. The only thing that's going to change is the brightness observed on the screen. So bright spots or the constructive interference becomes brighter, and no change to the dark phases, no change to dark regions, because they were already destructive interference. They were already destroying each other. So what is beyond even more destruction? They're already becoming zero. So there is nothing more to the dark band that is being observed. And of course, there is no change to the fringe separation, that is X. All right. So why has he said that the frequency is not changed? Because in AS, we have understood that intensity is proportional to amplitude square, right? We know that intensity is also proportional to frequency square, which is, of course, not a part of your course. But in some questions, I've seen that this helps you to figure it out. But anyways, that's why he's saying that the frequency is not changed, so that when you are thinking about it, you can keep the lambda constant. So when everything is constant, nothing is going to change. No pattern on the screen is going to change. The only thing is going to change is that the brightness will increase of the brighter parts that you're already observing. He says that the wavelength 660 is replaced by blue light, and I know that blue light has a wavelength of approximately 400 nanometers up to 400 nanometers. 400 becomes violet, purple, or indigo. 450 is actually the blue light. But anyways, there is a gap between them. Okay, this is what's important. State and explain the change, if any, made to the separation of the two slits so that the fringe separation screen can remain same. You see what he's asking you. So listen carefully. AX equals to lambda D. So he says, what should I do with A so that a fringe separation remains same although I am decreasing the wavelength? What should I do with this? You see, I want to keep the X as a constant, the D as a constant. So what is the relationship actually about? It's actually being discussed between A and lambda. Lambda has changed from 660 to 450. So if you've decreased lambda, how should I keep the rest of the things constant? I should decrease A as well. So mathematically speaking, A will also decrease, right? So that the separation and the distance and rest of the things can remain constant. So this is what you will find in the question as well, that A is proportional to lambda, right? So decrease the gap, or decrease the gap width, right? Or you can say reduce the distance between A, or reduce the distance of A, which is this gap. So you have to decrease this gap. You have to make it smaller. Anyways, question number 6. There is a proof for resistance. He says, tell us and show us that a series, the resistance is going to look like this. So what we know so far, the current remains constant, right? In a series circuit, the current is constant, and we know that the voltage is divided. Voltage is divided among all the resistors, right? Okay, so what I can say is that if this is V1, then V1 plus V2 plus V3 will be equal to the battery voltage, which is VB. Okay, so starting from this point that voltage has been divided, we say that the total voltage of the battery is being shown up or will show up in the three resistors. We know that Ohm's law is equal to V equals to IR. So let's replace everything in place of in terms of Ohm's law. So this is going to be I into R total, the total resistance, equals to I into R1 plus I into R2 plus I into R3, respective voltages, right? And since we know that the current is constant, it will be cancelled out from this side by taking a common, dash I into R1 plus R2 plus R3. This is common, so that cancels out. So we are left with RT, or the total resistance, is equal to R1 plus R2 plus R3. So that's the logic behind series resistors being added together. And of course, this proof is a part of your course. A battery has this, okay, every value is given to us, negligible internal resistance, okay, thank God. The switch is added, okay, over here. The resistor R1 has 6,000 ohms, R2 has 4,000 ohms. Okay, fine. He says the switch X is open, which means that effectively speaking, the current is going to go through this path. And this circuit is not a part of the discussion, at least. So I can see that the resistors are in series with each other, okay, when X is open. So he says, calculate the potential difference across R1. We want to find the difference across R1. We have a potential divider formula. We can very well use that formula and see what's going to be the answer. So 6,000 divided by the total resistance, which is 6 plus 4. So that is going to become 10. A simple ratio method. What is being shared? 8 volts are being shared between them. So let's multiply this with 8. So we get our answer as 6 divided by 10 into 8 equals to 4.8 volts. And by the way, you could have done this, could have done it in this way. V equals to IR. Voltage is 8 volts. Current you don't know. Resistance is 10 kilo ohms. First find out the current, whatever that current is, and then assume that that current is flowing through this resistor as well, and then apply V equals to IR to find out the voltage. You will still get 4.8. But that is a longer method that is going to take more time. So a more efficient approach would be to use potential divider since they are in series. He says now switch X is closed. Okay, fine. The resistance of thermistor is 12 kilo ohms. Calculate the current in the battery. No problem at all. You see now the circuit effectively looks like this, that there is a resistor of 6 kilo ohms over here. Then we have a resistor over here that is of 4 kilo ohms. Probably this is what's, 4 kilo ohms. And another resistor is 12 kilo ohms. This is what the circuit looks like. We want to find out the current in the battery or in the circuit. So how do we do that? First, we find out the equivalent resistance because they are connected in parallel. So let's apply the formula. There is a shortcut, of course. What you could have done is use 1 over 4 plus 1 over 12 equals to 1 over R. But we know that when there are two resistors, we can apply a shortcut, that is product over sum. So 4 multiplied by 12 divided by 4 plus 12 is equal to the total resistance represented by them, which is going to be equal to 3 kilo ohms. By the way, this product over sum, the shortcut of product over sum actually comes from this mathematics LCM. So no need to worry that this is something new. This is actually a simplified version of the formula that you're going to use eventually, right? Or you can use this formula to finally find out that R is going to be equal to 3. Anyways, so it means that in place of these two resistors, I can simplify my circuit that it is in connection in series with a 3 kilo ohms resistor. So what has that become now? It has become two resistors in series with each other. So simply put, we have V equals to IR, and to simplify them even further, they will be added together, right? So voltage is 8 volts, current is what we don't know, and resistance is going to be 6 plus 3, 9 kilo ohms. So I is equal to 8 divided by 9,000 because it's kilo ohms. So this is going to come out as I equals to 0.89 into 10 raised to the power minus 3, which matching the marking scheme is going to be 8.9 into 10 raised to the power minus 4. Granted, right? All right. So now we move on to part C. Switch X in the circuit remains closed. Okay, fine. The temperature of the thermistor decreases. Okay, fine. By reference to the current in the battery, state and explain the effect, if any, of decreasing temperature on the power produced by the battery. You see, if you, let's discuss it over here. He says that temperature is being reduced, right? It is being cooled down. So we know that from memory that the resistance of thermistor is inversely proportional to temperature or heat. Now you're reducing the temperature because you're cooling it down. So its resistance is going to increase, right? When you increase the resistor or increase the resistance, let's say previously it was 12 kilo ohms, right now it is 20 kilo ohms. Now, when you use the formula 1 over 4 plus 1 over 20 equals to 1 over R, the answer of R is going to increase because previously the combined resistance of both of them came out as 3 kilo ohms. Now, if you do this, it will be a bit larger. Let's try that. See, we are changing from 12 to 20. For the sake of understanding, let's try this example. Okay, what's the resistance now? When you do this, the resistance comes out as after the parallel combination, right? So 1 over 4 plus 1 over 20. This comes out as 3.33 kilo ohms. Now notice, previously it was 3 kilo ohms. Now it is 3.3. The resistance that is going to be replaced in place of them, right? So let's say that this was 6 kilo ohms. And now this is 3.33 kilo ohms. So if I had to use V equals to IR again, 8 volts into current into 6 plus 3.33. I am dividing 8 with the number previously that was 9 kilo ohms, right? Previously it was 9. Today it is 8 divided by 9.3. So if I'm increasing the resistance, the current will decrease. So all of this is done with a hypothetical example, but this should happen in your brain just theoretically, right? We know that the overall resistance is going to increase. First, you have to state what's going to happen. What's the thought process? So the resistance of thermistor increases. The overall resistance or the combined resistance of the parallel combination, you have to state this, of the parallel combination also increases. As we've seen in the example, it increased from 3 to 3.3. You can try this with any other example as well. You can take 25, you can take 30 ohms to make it more understandable, right? So the resistance of the parallel combination increases. The resistance of the total circuit increases, leaving behind that the current is going to decrease. Now, when the current decreases, the formula for power is equal to P equals to I square R. Now, when the current is decreasing, the power is also going to decrease. Now, there could be an argument for this, that the overall resistance of the circuit has increased. You see, previously, the resistance was 9 kilo ohms, total resistance. Today, with my assumed example, is 9.33 kilo ohms. So the resistance is increasing. Then why the power is not being affected? You see, you have to notice the mathematics of this. You see, the formula actually goes by P equals to I squared R. Even though R has increased from 9 to 9.33. Okay, fine, granted. But the value of current, that is whatever the value may be, when it is going to get decreased and squared, the effect of decreased current will be much greater than the value of the increased resistance because of mathematics, right? The effect of the square power is going to be greater as compared to R. So the overall power is going to reduce. That's why the answer of this question will be that the power is going to get reduced based on this idea that power is proportional to I square R. Okay, so I hope that we understand a lot of things by this question. Okay, question number 7, straight away radioactivity questions. Beta, we know that this is 0, -1. This is 0, 0. This will be 137, not affected by number. And this will be 56. Let's replace all of them over here. 0, 137, -1, and 56. Okay, because we know that charge is conserved. For the upper part, the equation was going to go like this. 137 equals to x plus 0 plus 0. And for the lower part, it would have been gone like this. 55 equals to this s plus this -1 plus 0. For beta, we would have memorized. For this, we actually find it out on the spot. He says, what is the group name of the particles for beta? So we know that they're called leptons. So beta positive, beta negative, neutrinos and antineutrinos both belong, all 4 belong to leptons. He says Y has a quark composition of down, down, down. D represents down quark, which is -1/3e. Z is a quark composition of anti-up and down. Anti-up represents the anti-up quark. Okay, so that would have a charge of -2/3. Show that charge of particle Y and Z are equal. So let's do that. So Y has 3 downs, right? So 3 multiplied by -1/3 is equal to -1e, elementary charge. Okay, let's do that for particle Z. So for particle Z, we have an anti-up, which is minus 2 by 3e, and a down charge, which is minus 1 by 3e. This comes out as 1e again. So you can say that hence shown that charges are equal. You have to remember this, right? So you have 6 quarks that you have to remember. You have up, down, bottom, strange, up, down, top, and charm. These are 6 quarks that you have to remember, and their respective charges as well. But that is how we are able to identify, and at least we are able to discuss it with the examination point of view. What's that? He says which particle is a meson and which particle is a baron. So this is also supposed to be a part of your memory. Mesons are made out of 2 quarks, and barons are made out of 3 quarks. And the special quality about mesons is that one particle will be a quark itself, and the other one will be an anti-quark of the other particle, right? So for barons, they could be, for example, up, down, 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 up, up. We don't care, right? So how do we justify which one of them is which? So I can see that Y is made out of 3 quarks, so this must be a baron. So Y is a baryon, and that is, and the reason to justify this is you will say that it has 3 quarks. And Z or Z is a meson because you will say that it has a quark coupled with an anti-quark. This is special for mesons, right?